Today we're going to be learning about the basics of trigonometry. Now, essentially for trigonometry, at the moment we're going to be concerning ourselves with a right-angled triangle. Now, we're going to call the one side A, the other side B, and the hypotenuse C. We're now going to introduce the three most important characters for trigonometry, namely sine, cos, and tan. If we call that angle between A and C theta, then we would be looking at sine theta, cos theta, and tan theta. Sine theta is just the opposite side over the hypotenuse, so the side that's opposite to the angle theta over the hypotenuse of the triangle. Cos theta is the adjacent side over the hypotenuse, so whatever side is adjacent to our angle, and tan theta is the opposite side over the adjacent. Now, how does this apply to the triangle we've created? Well, if you look at theta, the side opposite to it is B. So it'll be B over the hypotenuse, C. The adjacent side is A, so it'll be A over C. And then the opposite over the adjacent would be B over A. Let's look at an example of how this can apply. Let's create a triangle with one angle being 60 degrees, one being 30 degrees, and then one side being the square root of 3, one side being 1, and another side, the hypotenuse, being 2. I'd like for you to follow along with me. Try to figure this out for yourself. What would the sine of 60 degrees be? Well, let's look at the angle 60 degrees. And pause this if you want to try it yourself first. We know that sine is going to be the opposite over the hypotenuse. And we can see that the opposite of 60 is going to be the root 3. And we know the hypotenuse is 2. Let's now try cos of 60 degrees. Again, I would like for you to try this on your own before you just listen to me go over it. So pause the video if you'd like to try it. We know that cos is going to be the adjacent over the hypotenuse. So what is adjacent to 60 degrees? That would be 1. And the hypotenuse was 2. So we get 1 over 2, a half. See, it's not so bad. It's just breaking it down into more doable pieces. Let's look at what are known as the special angles. Those will be 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, special angles are angles that give you a really nice answer. So, as you'll see in a moment, I'll show you what kind of answers these special angles will give you, and I'll show you how to remember them. Now, a very easy way to remember these angles is to remember the following triangles. Oh, and 0 degrees is another special angle. I'm sorry. The following triangles will be really helpful for you to remember the special angles. So this one's a really easy one. It's just a right-angled triangle with the sides being 1, 1, and root 2. And because it's an isosceles triangle, the two angles will be equal. So they'll be 45 degrees. So that's the first special triangle. The second one will be one with 60 degrees, 30 degrees, and again 90 degrees because we're working with right triangles. And the sides will be 1, root 3, and 2. It's very important that the sides are in that order. The opposite side of 60 degrees must be root 3. So basically, these are the only two triangles you have to remember. You can get your special angles by using sine, cos, and tan of these angles that I've shown you. So you'll see that sine theta, sine 60 degrees, will be root 3 over 2, and that's a special angle. So it's just important to remember these triangles. It's also important to remember that sine of 90 degrees is 1, cos of 90 degrees is 0, sine of 0 degrees is also 0, and cos of 0 degrees is 1. So sine and cos are opposites in a way. So here's a really nice question. Using a special triangle, let's find cos of 45 degrees. Now, what triangle did we find 45 degrees in? That's right, the one with 45 degrees in both corners and 1 being the length of each side, root 2 being the length of the hypotenuse, which you could find with Pythagoras, and we know that that's a right triangle. So cos 45 will be the adjacent, which is this one, because remember that the opposite will be that one. And although they are the same in this case, it's good to remember which one is the adjacent and which is the opposite. So cos 45, we know that's going to be the adjacent over the hypotenuse. And what's the hypotenuse? Well, we know that that's going to be root 2. So, looking at our information, we can already see that cos 45 has to be 1 over root 2. It's not so bad, is it? Let's try another one. What about sine of 45 degrees? Can you get that one? Pause the video and try it on your own before seeing what I say. Well, we know that sine is nothing but the opposite over the hypotenuse, and we can already see what the opposite is, and we've written what the hypotenuse is, so we know that it's going to be 1 over root 2. Using what we've worked out, what can we conclude from this information? We can see that cos of 45 degrees is equal to sine of 45 degrees. That'll be it for today's video. I really hope that you've learned something, and if anything that I said was unclear, be sure to ask me about it in the comment section or send me an email, which I'll include in the description. If you have any suggestions for future videos, also just let me know, and I'll be sure to cover any topic that you'd like. I'll soon be posting a new video about the more advanced things of trigonometry, such as more identities and some common problems that tend to be asked in exams, and how we can easily tackle them, and how you'll be able to get a really good mark for trigonometry in your next test. Until then, I wish you all the best in your studies, and have a great day.